now introduce advantage actor-critic model. Reinforcement learning methods include two major methods. One is a value estimation-based method like Q-learning and TD. Another one is a policy gradient-based method like reinforce. In some cases, if we can combine two methods together, we can get a more powerful method. So let's see Q-learning based method like a double deep Q network use a gradient descent method to train the reinforcement learning model. Here is the loss function. From this, use the gradient method to train this model, by calculating the gradient of this objective function or loss function. And then we update the model parameters and to find the optimal policy. Here, the D is the experience replay buffer. And this first term is a target. And the second term with his current state value function. And the second method, a policy gradient-based method is reinforce. Reinforce is we use policy gradient to represent this gradient of the objective function. And here, this is the return. Let's say using the Monte Carlo sampling. However, if we use the Monte Carlo sampling, this G will have no bias, but has a larger variance. To reduce the variance, we introduce the baseline. This baseline, state value function because it only depends on this state. So it's a better choice to be used as the baseline. So without this baseline, we call this a reinforce method. With this baseline, we call this a reinforce with baseline model. However, in both cases, we just use this state value function as a baseline. We don't bootstrap this state value function. And then to get a better result, we use this baseline or this state value function as a critic, and use the policy as an actor. So we use this actor to generate a policy and use this state value function as a critic to evaluate the policy generated by the actor. That's called the actor-critic model. From his formulation, it seems, the definition of the advantage function. So we can define this term as a advantage function. So we can update. We can use this advantage function as a critic to evaluate the policy generated by the actor pi. That's called advantage actor-critic policy. And also we can define this difference as the temporal difference error. Then we use the temporal difference to update this, use this temporal difference error as a critic to evaluate the policy generated by this actor pi. The actor pi is used as an actor to generate the policy. That's the several ways based on the reinforce method. Let's see what's the actor-critic model. In the standard reinforce method, we use this policy gradient to express this gradient of the objective function. And here is the return. We use the Monte Carlo sampling to get this return. And this coefficient just like eligibility trace vector. And as we mentioned, because this Monte Carlo sampling has a larger variance, to reduce the variance, we introduce the baseline. use the baseline just use to reduce the variance. Because this baseline is only depend on the state S. So the best choice is we use the state value function as this baseline, because this state value function also is just depend on the state S. But in both, in this reinforce with the baseline model, we just use this state value function as a baseline. We don't update this state value function. So that's called the reinforcement method. In the actor-critic model, we update both the policy and the state value function. That means use this policy as an actor to generate the policy and use this state value function because we update this one to evaluate the policy generated by this actor pi. According to the definition of the advantage function, A is equal to the action state value function Q minus this state value function V at the state S. This Q is just we use to describe this state and this action A. That means when we use talking about the Q, an agent stands at this point. This state value function just describes this state is good or not compared to others. Right now, we introduce this advantage function, which is the agent stands here. Use the actions to describe the state value function. So the difference between advantage function and the Q function is that when we talk about the advantage function, an agent stands here. When we talk about the Q function, agent stands here. So just for different application, we use A or use Q better to describe our applications. So once we have this from this definition, then we can replace the Q minus V with this advantage function. Then we got this is a gradient of the object function, and here is a policy gradient, and this is the advantage functions. So then we can use the temporal difference to calculate, to update this advantage function. And this first term is target, second term is his value at state S. So if we use this advantage function as a critic to evaluate the policy generated by the actor pi, then we get the advantage actor-critic policy. Then we define two loss function. One is LA, one is L pi. Because the advantage function A and the policy pi, they share the same input and the same convolutional network. And then we just use two different output modules. One is for the advantage function, one is for the policy pi. So we use two output modules. Let them, like say, this policy generate a policy. If this policy is better, then we use this, we use this advantage function as a critic to evaluate this policy. And then we use this advantage policy. Then we find the new policy, and so on. And this is very smart because if, for example, if this advantage is better, then we'll encourage find the better policy. If a policy is better, then use this policy to encourage this output model generates a better advantage function. And finally, we reach the convergence status. Once we have a convergence, we can use these model parameters. We generate the optimal policy, and we generate the optimal advantage function. For more details, please check with this reference. Thank you. Bye.